is Chonchunwa. My metric number is AE170122.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Samsida binti Rusmai. My metric number is CE170165.
Assalamualaikum and hi, my name is Farisha Husna binti Zaidi and my metric number is AE170133.
Hi and Assalamualaikum. My name is Fatin Izzati binti Fahmi Rizal. My metric number is AE170051 and I'm presenting the objectives and methodology in this video.
Assalamualaikum. My name is Haizatun Nur Soleha binti Hairudin and my metric number 107137.
Hi and Assalamualaikum. The theme given for the Integrated Design Project 1 IDP1 was Smart Agriculture, and we are from Section 2 Group 9 chose grass cutter using IR remote and sensor as our title. I am Farisha Husna as the first representative from this group will present to you about the introduction, but before that, I want to share about the evaluation of the lawn mowing. Okay, this is some ideas for the hardware design. As you can see from the front view, you can see the handle. From the bottom view, you can see the blade and the string. The string is to cut the grass. And from the side view, you can see the lamp, the tires, and the case. The case is to put the sensors. Okay. For your information, lawn mowing and grass cutter is the same thing. A while ago, it takes 60 goats about 3 to 5 days to clear out a quarter of acre dense land. Then, moving to 500 BC, the scythe was used by the ancient Romans. After that, reel mower was invented in 1830 by Edwin Budding after seeing a machine in a local clothes wheel. In 1940, rotary push mower was invented and it had a 708 horsepower engine. Soon later, in 1963, the riding mower was invented and it also called as hustler. Finally, in this new era, in 2016, the robotic lawn mower was invented with many other technologies. For the introduction, machines for grass cutting are popular amongst workers in agriculture, gardening, landscaping, horticulture, and etc. Grass cutting is hard work, arduous task, while motor power push grass cutter and riding grass cutter create noise pollution due to the loud engine and local air pollution due to the combustion in the engine. Environmental pollution keeps increasing and it can be experienced in our daily life. Based on a study, it is reported that 70% of Malaysian home citizens are utilizing fuel-powered grass cutter for their daily grass cutting routine. Grass cutting cannot be easily accomplished by elderly, younger or disabled people. People might hire a lawn service to do it. Luckily, modern tech companies have noticed the problem and that mowing a garden can present and have came out with a nifty solution, which is the robotic grass cutter. It can work in the morning when you are indoors. In this project, the grass cutter using IR remote and sensor is a grass cutting machine that has a remote control capability. This grass cutter design operates when button on the remote is pressed and send the infrared signal to the IR sensors in the coded form. When the IR sensors receive the signal, then it will pass it to the Arduino.
Hi, I'm Farah and now it's my turn to explain about problem statement. First of all, we usually see the grass cutter machine in the agriculture sector are commonly the manual method in which the grass cutter is being moved by human effort, and this is getting outdated method these days. A little behind with the modern flow and use of sophisticated technology. Next, The task of cutting grass is something that the older and younger people find difficult. This caused by the lower efficiency of the manual grass cutter machine. On the other hand, grass cutter moving with engine create noise pollution due to loud engine and local air pollution due to the combustion in the engine. Lastly, it also used a motor as power engine and it required more money for its periodic maintenance such as changing the engine oil.
Hi, my name is Fatin. Now, I want to present about the objectives of this project. The main objective of this project is to design and innovate prototype for agriculture. Thus, the sub-objectives are, the first one is to develop a simple operating grass cutter with the implementation of infrared technology. Next, to design a compact size and portable grass cutter that easy to move from one place to another place. Next, to design an environmental technology EnviroTech grass cutter with low cost budget. Last but not least, to develop and implement an anti-vibration mechanism to grass cutter.
We will move to the scope of the project. First, IR remote control support short range, which is it only operate and sense within 30-meter distance. It required line of sight between transmitter of grass cutter machine and receiver to communicate. Infrared frequency easily affected by hard objects such as door or wall. This grass cutter machine can control by one device only. Last but not least, this grass cutter machine only focus on use for cutting the grass.
I am Fatin. Now, I want to explain about the methodology that we use to complete this project. First, let me explain about the components of attachment. The components that we use are Arduino Uno R3, DC motor, IR sensor, jumper wires, 220 ohm resistors, 1K ohm resistor, and remote control. Now, this is the second part of methodology, which is the working of Arduino grass cutter. This is the flowchart that we use to make the Arduino grass cutter using remote control. First, we start the device. Then, we go to the input which sends signal infrared. Next, we will navigate by the IR sensor. Then, we go to the process information by the microcontroller. And lastly, go to the output by DC motor, and that is the end of this flowchart. Now, this is the working of Arduino grass cutter. This is the flowchart of project design. First, we start. Then, we start to design the Arduino grass cutter. Next, we simulate the grass cutter by the software, and then we go to the grass cutter is able to function or not. If the grass cutter is able to function, we will go to the end of the process. But if the grass cutter is unable to function, we go to the troubleshooting problem. In this process, we will see either the problem is solved or not. If the problem is solved, we will end the process. But if the problem is not solved, then we repeat the process at the design Arduino grass cutter. We will repeat this process until we got the solution of the problem. Then this process will end.
Hi and good morning to everyone. I'm Chun Chun Wa. Now, I would like to present about the result, analysis, and discussions. In this project, we are going to control the DC motor using an IR sensor and a remote. Now, I would like to explain the result. How does it work? Whenever a button on the remote is placed, it will send an infrared signal to an IR sensor in the quarter form. The IR sensor will then receive this signal and will give it to the Arduino. We will set the code for the buttons that we want to control the DC motor in the Arduino code. Whenever a button on the remote is placed, the Arduino receives a code. The Arduino will compare this code with the codes already saved, and if any of them match, the Arduino will turn on the DC motor connect to that button. So, this is the circuit diagram. From the circuit DC motors to the Arduino, we connect the positive of the 5 DC motor to the pins 2, 3, 4, 5, and 13. We connect the negative of the 5 DC motor to the ground on the Arduino through the resistors. The red pin of the DC motor are positive and the black pin are the negative. Then we connect the IR sensor to Arduino. We connect the negative wire on the IR sensor to ground on the Arduino. We also connect the VCC pin of the IR sensor to 5V on the Arduino. And we connect the signal pin of the IR sensor to pin 11 on Arduino. Now, I would like to explain the coding. First of all, we added the library for the IR sensor and remote. Then we define the pins which we have connected to the DC motor. We have connected the DC motor at pins 5, 4, 3, 2, and 11. So, we define these pins as the motion and direction of DC motor pins, which are left, right, forward, backward, and the receive pin which represent the cutter. In the setup function, we define the DC motor pins as the output pins because we are giving the output to the DC motor through those pins. In the loop function, this line shows the Arduino will return true if anything is received and store info in variable result. The next line is to make Arduino get the value of results as an unsigned integer, so we can use switch case. We define the codes for the keys that we are going to use in our project. First, we check if any keys has been placed. If any key has been placed, then we compare that key with the key that we have defined in our code. If the key match, then the DC motor connect to that pin will on. When the DC motor connect to that pin is already on, then it will off after the delay. Thank you.
Assalamualaikum. My name is Haiza. I will explain about the challenge to complete the project during MCO and the simulation part. The first challenge to complete the project during MCO is unable to have a proper discussion. The only way we can have a discussion is only through Google Meet and WhatsApp group, which is not efficient compared to face-to-face discussion. This way of discussion will cause a miscommunication among us. Next, facing a problem with internet. Because the 5 of us are not in UTHM, we in our own hometown, so we are facing the problem with internet. It will be hard for us to find and do a research about our project if we have a bad internet connection. Next, it is more challenging to complete the project at home because we have no friends to refer and to brainstorm together. If we have someone physically, it will be more easier to have a discussion and brainstorming the problem together. Okay, next for simulation part. We are using 5 DC motor for 230 ohm resistor and one 1K resistor, IR sensor, and Arduino Uno for our circuit. So we already upload the coding in the Arduino, right? Okay, next, to run the motor, I will start simulation. The first motor is the motor for the cutter machine, and the rest is for the tire. For the tire, to move all the other DC motor, you need to push 1, 2, and 3, 4 button. And for second motor, okay, for simulation, this is the only remote control that have in this tinker card. So it's not too efficient. For our hardware, we are using a better remote control to control the cutter machine.